Hello guys and welcome to general introduction that will help you to level up your programming skills. I'm Tech Teacher Vlad, this is Alpha Tech and a general introduction, here we go. So before getting into all the technical stuff, we need to understand what is a program or an application, who will use it and who developed it. This application may either be simple or sophisticated, like the well-known YouTube, Facebook, Twitter, and yes, even WhatsApp. So basically, we can say that every application has two main sides. The first one is called the user or the customer, and the second side is called the developer. So for every app you've ever used in your life, there was someone who developed it, while you were just sitting, playing around with this application, just using it. I think that makes sense, right? And while that's great to use other apps, it's even better to develop some on your own. And that's exactly what we are going to do in this course. In this course, you'll be on the developer side and you will learn how to develop different apps. Although we're not going to develop complex apps like YouTube or Facebook because this course is mainly for beginners, but still we'll cover different programming aspects that are mandatory for developing the more complex apps in the future. So during this course you'll plan and develop different programs that do something for you, something you wanted them to do. And that's one of the most fascinating things about programming, to create something of your own. To create something new. So, are you ready to become an amazing developer? I guess you are, and I hope you are. And with that being said, let's move on. Alright, so in this video we'll talk about how we should look at our computer. I want you to think of it as a unit that just executes the commands you ask it to do. You provide it with some commands and it does all the necessary actions. For example, you may ask your computer to calculate something for you, for example, your average grade. You simply ask it, the computer says, okay, sure, I'll find out, and then he says you got an outstanding grade. Also, you may tell your computer to show you some image or to play some cool video, right? You may also ask your computer to surf the internet or basically go to different social medias for you, and actually you can do much more with it. The computer should simply help you with whatever you need by following your instructions. So basically your computer may follow a lot of different commands or instructions you ask it to do. You ask through some input and you receive the results on the output. Simply ask and receive. Nothing more. And if you would like to hear some cool analogy that will probably help you understand this topic even much better, let's take a look at the restaurant example. I want you to imagine a situation where you sit at some cool restaurant and you want to order something. You are a customer in such a case, right? Okay, so now we have you as a customer, and I also want you to think of a computer as a waiter that works at that restaurant. And you want to grab a drink, so you simply ask for a drink and then the waiter will give you what you asked for. You may also ask for something to eat and the waiter will give you what you ordered. And if you're not sure what exactly you want, you're probably going to ask what different drinks the waiter can suggest. And then the waiter will tell you, or better say, give you some response with the suggested drinks. And that's a very similar situation to how we work with computers. We simply ask to find out what are the best drinks on Google, for example, or on Yahoo, or any other search engine that you may be familiar with, and then your computer will follow the command and go searching on different websites for the desired requests and then come back with a relevant result, the list of drinks that you asked for. So now we know that the computer will follow our strict instructions. Just need to ask for something and then the computer will hopefully find it and we'll get and receive our result. So simply ask and receive. That's the whole structure, the main structure, let's call it this way. But how, or better say, in what way should we ask our computer to do what we want it to do? Maybe we'll need some additional parts, like a mouse and a keyboard perhaps, so that it can be used as some sort of input, right guys? And where should we see the expected results? Should it be on a piece of paper, maybe using a speaker, or maybe even monitored on some display? These are very good questions, and we are going to discuss this restaurant example even further in the next videos, so we are not finished with it yet. And that's very important, guys, because even if you don't see it by now, these topics are the ones that shape your programming skills and make you a better programmer. A programmer with a system vision and understanding. Not everything is just code, believe me, although we'll taste a lot of it too. So we're just getting started, let's go to the next section. What is going on, guys? And in this video we are going to talk about the computer and its additional common parts. Our great computer simply executes the commands we provide it with. We just ask the computer to do something, for example, to calculate your average grade, right? And it goes executing our request. Once it's done, it gives us its answer, the calculated average grade, as in this example. But how the computer should know what commands we would like it to do, what commands we would like it to execute? Maybe we should just say it out loud, tell our computer what we would like it to do. Just scream it out loud, or something like, "Hey dear computer, could you please calculate my average grade?" And then expect your computer to do what you asked for. So there are many ways to do so. Let's say, the most basic tool, which all of you are probably familiar with, the keyboard. We'll use it as a tool that will help us in communicating with the computer and actually to deliver the message we want to ask the computer to execute. So for example, we'll use this keyboard to type down the request to calculate the average grade. There are also a lot of additional tools or parts, you can call it this way, which can be used as input for your computer, like microphone, mouse, and many more. But for this course, when we learn the basics of programming, we'll just be using the keyboard. So, we know that the keyboard will be referred to as the input to the computer. And what about the output? How can we know if a command has been successfully completed? We need a place where we can just see the results of the average grade, for example, right? And for that, we have the screen part, the display part. If you would like to calculate your average grade or to see some cool movie, you would expect to see these results on your display. So we are talking about additional common parts of the computer, and although in desktop computers the separation between the computer itself, which we said is just like a unit to execute commands, its input components such as the mouse and the keyboard, and the screen or the display where we'll see our results, that separation is actually very easy to notice. On the other hand, in most laptops, this separation is not so easy to notice. Meaning, it usually seems like the laptop is just one big unit, which contains everything mixed up together, including the executing units, the keyboard, and the display. But actually, even if it looks this way, the separation between the keyboard, the executing unit, and the screen is still there. It's just that now you cannot clearly see it. The connections are sort of hidden from you. But make no mistake, they are still there. Alright, great, let's move on. So let us take one more look at the basic architecture. The keyboard, the computer, and the screen. This is the most basic usage we'll have in this course. The commands we want our computer to follow are going to be inserted by using the keyboard. Basically, we're going to type the commands we want our computer to do by using this keyboard friend. The computer will then execute and calculate your average grade, and the output of the execution will be seen on the screen. The question about how you are going to see the output, the results of your application on the screen, whether it's going to be colorful or interactive or just on a blank screen, depends on the general understanding of what is a user interface and what type of user interface we are going to use in our course. Actually, let me know if you would like me to make a short video explaining this topic. But basically, in our course, we are going to use a console application. Just a small, cool black screen. You'll get used to it. And in the more advanced courses, once you'll have all the basic skills, we'll develop some apps which are much more colorful and much more complex. But until then, there is a whole road that we should walk together. So now you know how to look at different parts of your computer, whether you have a desktop or a laptop. And I'll see you in the next video. Hello there, beautiful people! I'm Tech Teacher Vlad, this is Alpha Tech, and in this video we are going to talk about what is a programming language. And I want you to pay close attention to everything said here because from my experience, this topic, teachers don't give it much value and don't spend enough time on it. And I think that's one of the topics that all of you should be well familiar with. It will help you a lot in the future. So previously we said that the computer actually executes the commands we ask it to. And also we compared this computer to some waiter in a restaurant who simply executed our commands. And that was just an analogy, guys. Don't think that a waiter's profession is just like a computer. I mean, I'm just comparing it so it will be easier for you to understand the material. I also have been working as a waiter in many places for a couple of years, and trust me, that's not an easy job. So let's get back, and one of the main questions that should be asked is in what language should we ask the waiter to bring us this incredible piece of this amazingly delicious chocolate cake? Maybe we should ask for it in English. Something like, hey, could you please give me this amazing chocolate cake? And then the waiter will say, oh yes, of course, here is your amazing cake. And then you're going to be like, wow, that's good. Or should we ask for it in some other language, right? I mean, perhaps we speak different language and we still want this piece of cake. So what language should we use? Maybe we should still use English, maybe we should use Russian, Chinese, Hindi, or maybe even Japanese. Basically, we can use any language, right? We expect that we will be able to use any language to get our cake. Well, it depends. Depends on what? It depends on what language the waiter speaks, and also it depends on what language we're speaking, right? So if we both speak English, I can just tell the waiter to bring me this cake and he will understand and execute directly this command or request. And that's good. If both speak the same language, we do not expect any problems here, right? But what will happen if you and the waiter you both speak different languages? Suppose you speak only English and the waiter speaks only French. What will you do in such a case? How will you talk to the waiter and ask for your chocolate? In such a case, you should probably ask for some help. You should get in touch with some translator guy that will translate your request or your command from the language you speak to the language of the waiter, the language that the waiter understands. So then the waiter will be able to execute and do exactly as you've asked it to, and that was to bring that yummy piece of cake. And now you can ask basically for anything just by using the help of this translator guy. And now once we've got the idea of how to ask for a chocolate cake, let's talk about the relation of that analogy to actually what it has to do with computers and programming. Alright, so suppose you want to write a simple command that will just display or print a hello world message to your screen, to your display. And once you do so, you basically expect that some magic will happen and that the message of hello world will just somehow appear on your screen. Good. This hello world message is the first step of almost any programmer. So how should you accomplish that? Should you just tell your computer in English, please print to my screen hello world message? Or maybe should you say it in Japanese? Also, what language does the computer even speak? Does it speak Chinese or Japanese, or perhaps it has its own unique language? So for simplicity, let's say that every computer speaks only in one language, and this language will be called machine language. Just like there is an English language, Russian language, and many other languages, there is also a language called machine language. Some other language, okay? Which is just a language that the computers understand, talk, and use. So we, as humans, may speak our own languages, and that's okay. It depends just on where we are from And meanwhile, the computers speak their own language, called machine language. Is this okay so far? The instructions, the commands in machine language are represented as sequences of just zeros and ones, a binary language or a binary representation it's also called. So some combinations of these zeros and ones may represent to print hello world message to the screen. This 100 and 001 may represent exactly what you need, but just using some other language that you are not so familiar with. But can we humans even speak the machine language? Probably not. The machine language is actually very complicated, and that's why it's recommended to use some translator guy who could make our lives much more easier. We as programmers will write commands in some higher, more readable for us the humans programming language, like the one you're about to learn in this course, okay? This will basically allow you to express commands in a more convenient way than it would be in machine language. And although it will not be pure English or pure French, but still, this language will be much more readable for you. So once you've written your commands or your program in your higher, more readable programming language, we will simply ask the translator guy to translate these commands to machine language. Actually, the guy who does the translation thing from the language we've written to the desired or targeted machine language that the computer understands is called the compiler. And we will talk about compilers, maybe not a lot in this course, but in the next courses, in the more advanced courses, we will use it a lot. And once you've used this compiler, the computer will actually know what you wanted it to do, and it will execute your commands and display a hello world message to the screen. So to summarize it even more, you know how the process of executing commands starts with your higher level programming language, proceeds with some translation to the machine language, and then your computer doing that in practice, what you asked it to, executing the actual things you wanted it to execute. So I hope this makes clear, guys. It's a very important topic, and now I think you're ready to move on to your first program. Congratulations, you've made it so far, and I'll see you in the next chapter. Goodbye. Welcome back, ladies and gentlemen. And in this section, before we'll start writing any code, we will first of all need to download and install a couple of things. So we need to download and install an IDE, and an IDE stands for Integrated Development Environment. It's simply a place where you are going to develop your programs. And if we want to develop different things, we need a few tools and a few plugins. So instead of using multiple programs, an IDE allows you to have it all integrated in just one place. So now that it will be easier for you to just start working instead of setting up a lot of things on your own. And what I want you to know is that there are plenty of other IDEs out there that you can use. For example, you may have heard of Eclipse. Eclipse is an IDE that supports the development process in many languages like C, C++, Java, and even Python. And that's actually one of the most used IDEs today. We also have Visual Studio, which I've been working with a lot lately, but the problem with it is that it's not cross-platform and it's kind of heavy. So aside from these two, there are plenty of other IDEs that you will encounter in your programming life. Some of them are good for one thing, while others are good for some other things. So our choice for this course is that we are going to use an IDE called CodeBlocks. So from now on in this course, all of our future programs are going to be developed by using CodeBlocks. And the reason why we're using CodeBlocks is because it's good for beginners, it's light, meaning it's probably going to run smoothly for most of you, it's very extensible and configurable, and also it's cross-platform, which means there should be no problem for you to just download and install it without any concern if you're using Windows, Linux, or Mac OS. Oh, and one thing I forgot to mention is that CodeBlocks is free. You don't need to worry about paying for anything. This IDE is totally free. And I don't want you guys to spend any money for fancy IDEs at this point. It will be just a waste of money for you. But if you still want to waste some money, I suggest giving a little of that to charity and do some good in this world. If you still want to use other IDE, paid or free, that's also fine with me. There shouldn't be any major differences for this course and no actual problems are expected here. Just make sure you keep up with us in this course as we are using code blocks. So now, once you know what you're looking for and what an IDE even means, let's take a couple of minutes to download and install our code blocks. Alright guys, so first of all I want you to open up your browser and go to Google and here type down code blocks. So their official website is probably going to be ranked first, not including any optional sponsored ads. That's probably going to be it, codeblocks.org. Let's click it. And just to make everything clear, we need two main things. The first one is a place, some editor where we can write our code. And second, we said earlier that we are going to need the compiler for the translation from our programming language to a machine language. So that's what we are looking for. And although we can download these two parts separately, I want you to download both of them together, integrated as we said previously, and that all of this setup will be much easier for us and we'll get it done in just a couple of moments. So let's go to downloads, and what we can see here is that we have a couple of options. The first one is to download the binary release, the second one is to download the source code and also to get it from SVN. And what we want to do is to get the binary release, so press on it and then we can choose whatever operating system we have, whether it's Windows, Linux or Mac OS. For example, I'm currently recording this course on Windows, so I'm going to select that. And now we have a couple of options to choose from. By the way, if you're using Mac OS, then there is only one option for you to download, so that's even easier for you. And for those of you guys who are using Linux, take a closer look at the options and pick the right one for you based on your distribution. Okay, so for Windows users, we are going to download MinGW setup, because as you can see here in the notes, MinGW setup also includes additional GCC compiler. And let's leave aside this debugger for now, because what interests us here is that this binary file includes the compiler that we said is a must for us, right? We need this guy to translate the code from our programming language to a machine language. So let's go with this option and download it. The download should take about a couple of minutes, so you can pause me. I'll just skip this part to when the download is complete. And we're almost done. Yeah, now it's done. Okay. So once the download is over, let's move to the setup of code blocks. Click or double click the execution file. All right, press yes, press next. Read the whole license agreement. Alright, it's very long. Press I agree. Don't change anything here, just stick with the defaults. Press next. Now choose your destination folder and press install. I'll just leave it as is for now. Alright, so let it run for a couple of seconds, a couple of moments. It's going to extract everything that is necessary for us to get started. So give it a second. Alright, so that's over. And do you want to run code blocks now? So simply launch the application, and once it's open, basically we can say that you are ready to go. So that's code blocks. That's the code blocks that we've downloaded and installed this whole time, this whole section. Fantastic. I hope everything has gone smoothly for you in this video and that you are done with the download and setup of code blocks. Congratulations, guys. Now you are ready to move on to the next video where we are going to learn how to start a new project in CodeBlock. What is going on, guys? This is an Alpha Tech and we are at a C programming course. And in this video we are going to see how to create our first project in CodeBlocks. First of all, make sure that CodeBlocks is running. Then, to start a new project, press File, New, and select a project. Now, here you may see different templates for various types of projects that even some of them are used in very cool fields such as ARM, AVR, and Arduino, which you probably heard of, for working with different microcontrollers and sensors and, well, whatnot. It even may be used for the development of IoT devices. There is also OpenCV, which is used for computer vision projects, and there is also MATLAB template that basically provides you with so many things you can do with it. There is also Qt4 and Qt5, which are mainly used for creating graphical user interfaces. And basically, guys, there are plenty of things for us to cover in the future, but for now we're just getting started with the basics. Once we are good with that, I will hopefully create more advanced courses, of course based on your demand, and will go much further for becoming more professional, probably to become an alpha tech. So for this course we'll be working with console application, so select it and press go. Don't touch the skip, just press next. Here select the programming language, in our case it's C, press next. And now I've already selected my subfolder, I set it up to AlphaTech C Programming, so you may choose something of your own or just leave it as a default C code blocks. And now we should set up our project title. Let's go with something like AlphaTech First Project. Alright, press next, make sure that the compiler is set, finish, and basically you are ready to go. So if you'll take a closer look, you could see the name of your project that we've just created, AlphaTech First Project. And if you click that little plus sign, you're going to see a default C file that was automatically created for you, main.c. And this file is just sort of a template, let's increase it a little bit, and it includes real code written in our C programming language. And you can see here everything written in a sort of a text editor. The text that we are about to write here and the text you can see here is written in C language. And that's a very simple program that should simply print out hello world message to the screen. But for now it's just sort of idle, don't you think? And if you want to run it, you should first of all use the compiler to translate it to machine language, so then the computer will understand what's written here and what you wanted it to do. So to compile your C program, you should press the build button. It's right here. Press build. Alright, so it seems to be okay. And now you can simply click the run button, which is right here. Click run, and there you go. You have the hello world message displayed on your screen. The C program is running, and basically we are ready to go to start working with our C code. Well, I'm so excited, so let's go. What is going on, guys? And finally we're getting the chance to work with some real code and to make our first C program. I guess you're pretty excited, don't you? At this point you should already be familiar with different aspects that we've spoken of previously. We said that there are spoken languages like English, Japanese, and many others. But now to develop our own programs we are going to use a programming language. And in this course, the programming language we're going to use is C. This simply means that the instructions are going to be written in C language with its own format and its own language rules. Just like in English, you know that every new sentence starts with a capital letter and a sentence may end with a dot, the same will be here, just that we'll use a semicolon instead, rules that are unique for a C language. Alright, and now I want you to take a look at the default program that was created once we started a new project in CodeBlocks in the previous section. It's pretty much the same program, I've just changed a couple of lines in this template so it will be easier for me to explain. Let's go to our code. So the first thing I want to talk with you guys about is this line, int main. Basically what it means is simply specifying the entry point. You see, there are a lot of things written here such as includes, main, return, and in the future there will be also printing lines. And what we would like to do is to know from what point we should start running the real commands. Should it be from line 5 or maybe from line 10? And what the entry point, what this int main means, is that it's just sort of a container for a block of commands. And this block of commands is specified by these beautiful curly brackets. The left curly bracket specifies the beginning of the block, and the right curly bracket specifies the end of it. So every time your computer sees that int main and the block of commands, it seizes as, okay, from here on, okay, from right here, I will start running your commands. The first command will appear here, the second one here, and until I reach the right curly bracket, this is going to be the block of commands that I'm going to execute. So for now, for our first lessons, all of your code, all of your C commands, remember that they are going to be placed under this int main section. Alright, so also we have these two lines, include stdio and include stdlib. And what they do is that they simply allow you to include different functionalities into your program. For example, stdio stands for standard input output. And basically for now, it just gives us all the necessary functionality to work with inputs, such as reading information from the keyboard, and also to work with outputs, such as displaying different things on the screen. You do remember that both the keyboard and the screen are additional parts of the computer, right? And one is used as input and the other used as output. That's why we need to include the functionality of working with inputs and outputs in our program. So stdio, standard input output functionality. And how should we exactly use that? We'll see right away. So very good, guys. You see, it's not so complicated, right? Oh, and by the way, if we're to speak about this little return 0 line, which comes as the last command of the main block, think of it for now as just a command indicating that this program, this code, has finished running successfully. Basically, when your operating system executes a program and the returned value is 0, the operating system can assume that the program has terminated successfully. But more on that later on. Also, note that every command in C ends with a semicolon. Just like sentences in most spoken languages end with a dot, in C programming language, commands tend to end with a semicolon. And that's basically all you need to know about the structure of your first C program. Pretty easy, right? I hope that everything makes sense to you in this video, and now we can say that is enough for the theory, and we should open CodeBlocks and create a new project. It's time to practice. Finally, some hands-on. Let's go. Alright, so now what we want our first program to do is just to print out hello AlphaTech message to our screen. So then once we hit the run button, this program, this AlphaTech message will be, boom, just printed out on our screen. And to do so, we will first of all clean everything out of here and start with a blank page, okay? Now I want you to simply write the following lines of code together with me. First of all, we will include the standard input-output functionality to our program by including the stdio.h. And now we have our entry point, which is int main, and then we use the curly brackets, and here are going to be the commands of this block, all right? And the first command that we would like to use is simply a command that will take some text and put it out on the screen as we wanted it to. So this command in C language is called printf. And in C language, the way that we ask a computer to print out a sentence to our screen is done by using this function, this printf function. So simply saying if we wanted to print a sentence of hello world or hello AlphaTech, it would be done using these parentheses, and then all of the text that we want to be displayed on the screen will be placed under these quotation marks. For example, we can just use hello world message here, and at the end we should also add a semicolon. And then we should also use the return 0, right, which we introduced previously. And now we can run this program, build and run. And then let's see what, oh, here is our message. Hello world, just on the console application, exactly as we can see in the printf command. This is the text to be displayed on the screen. Leave it aside for now, this process returns 0 and the execution time, we'll discuss it later on. But for now, that's looking good, right? And we were asked to print out a hello AlphaTech message, so let's just remove this one, hello AlphaTech as requested. And I just want to show you guys that it doesn't matter what text you put in these quotation marks. It can be hello world, hello AlphaTech, or whatever other text that you are going to use in the next challenges, in the next exercises. So let's try to run and to build and run it. All right, so there you go. Here is your message. Hello AlphaTech. Good job, guys. And one thing to mention here that I want to tell you is that in these quotation marks we specify the exact text, or better say string, that we want to be displayed on our screen. And the exact text in this case is hello AlphaTech that appears between these quotation marks. And also you don't have just to use words, you may also use numbers, let's say 1, 2, 3, 4, 5, 6, 7, and then press on build and run, and then you can see 1, 2, 3, 4, 5, 6, 7 just on the console application as you expected. Also, don't forget to add this return 0 thing, because it simply specifies to the operating system that the program has terminated successfully. So to summarize what we've done here so far, we simply use the printf command, the printf function, to display some text on the console application screen. And that's very important to understand, because in this course all of our printed results are going to be seen on this console application screen, on this guy, okay? All of the results are going to be seen here, and also we'll use this console application to read information, to read some data from the user, but this will be in the next section. But for now, that's okay. We'll just look at this console application as the place where we are going to print some text, some data, all right? So hopefully everything works smoothly for you so far with no unexpected bugs. But if you still got some problems, take a closer look and see if everything written as it should be, that you didn't miss any semicolon at the end of each command, maybe parentheses not written correctly, or maybe something with these curly brackets. And if you still can't find why it's not working, please check out the FAQ section. Maybe somebody already asked a similar question. And now let's get back to the hello message we used previously. Hello AlphaTech, alright. And if we run it, we can see in the console application that there is this additional text that we don't even know where it came from. This text is a default text that you are going to see a lot. And you would like to keep some distance between this not so necessary text to your real output, in this case the hello message. And to do so, you would like to do some sort of hitting the enter button right here just before this default text starts, right? So you can get one line down. So luckily for us, we can do that programmatically. We can change or basically specify getting one line down by using the \n notation within the printf command. So it will look something like this. Let's add a new line here, so we'll just add \n. And now if we go and run and build and run this application we've created, we will simply see that there is a new line added separating between the real text that interests us to this default information displayed on the console application. Great, and basically you may add also this \n wherever you wanted it in your text. So for example, you may add \n right after every word in the text here in the hello AlphaTech, and try to print out something like this. Let's go it this way. All right. And now if we'll run it, we will see that every word is printed in a different line. So here, hello AlphaTech. And this space is because we just specified the \n right here. If we move it a little bit to here, right? So we don't give it an option to start a new line with a space and \n after this guy. All right, let's try to run it once again. And there you go. You can see the hello and alpha and tech. Everyone is specified in a new line, the hello, just by using this \n guy. And now we can say congratulations for writing your first program. Now let's practice that knowledge with different cool exercises, different cool challenges that will help you to improve your skills. Welcome back, guys. It's time for an exercise, for a challenge. You're about to write down your first program on your own. At this point, you know that the printf command just displays what is written in its quotation marks, and also you know that \n, when used as part of the printf command, simply represents a new line. So the program you have to write should be very simple. It should print to the screen your first name and your last name. For example, if your first name is Bill and your last name is Clinton, then you should print to the screen Bill Clinton. So good luck, guys, and take your time to make sure your great name appears on the screen. And in the next video, we are going to go over the exercise together, so no worries about that. I'll see you there. So, how was your first exercise? I hope it was good. I hope you finished that successfully. And just to go over the things here, we'll do it together. So first of all, include stdio.h to include all the functionality for working with input and output. Then we'll just go to the main section to create the entry point, int main. And then we'll use the curly brackets to specify the block of commands. Now we know that the command that prints information to the screen is simply the printf in C, so we'll go like printf, and then we'll use quotation marks. And we said if my name is, for example, Bill Clinton, we'll just write down Bill Clinton. We'll also add the \n to jump one line from the default text, semicolon at the end of the command, and of course return 0. Now let's go and try to run it, so press build and run. And there you go, you can see your name, Bill Clinton, in this example, displayed on the console application screen. So very good, guys. And if you wanted to specify just the first name on the first line and the last name on the second line, so you would just need to add a \n also here, alright, before the last name. So now if you try to run it, okay, let's go here, you will see the first name here and the last name on the next line. Very good. And if we want to go one step further, we can do something like this. First name is Bill, and then we will just expect this sort of message, first name Bill, to be printed on the first line, and then we will have a new line, and on this new line we will see this message, last name is Clinton. Alright, so there will be separation between them, and also some nice visual information of first name and last name. Now let's try to run it and see the results. And there you go, first name Bill, last name Clinton. Alright, guys, so this is it for this exercise, and I hope you did it well and you learned a couple of things in my explanation here. And the last thing I want to tell you guys for this video is that practice makes progress. So keep on working hard, and I'll see you in the next video. Bye. Hello, ladies and gentlemen, my name is Vlad, and this is an AlphaTech C programming course. And in this video we are going to do our second challenge. Now, once you know how to print your first and last name on the screen, your second exercise is to print more interesting information. For example, suppose that you have the most innovative social media application that stores some interesting information about you, like your full name, your age, and your gender. And before talking about how this storage is actually managed, let's talk about how this information can be printed. So this is just a part of our general system, and we want to see how it will look like if we printed out a few lines that describe your name, your age, and your gender. So the output on the screen should be something like Brad Pitt, or as its real full name says, William Bradley Pitt. Alright, so the full name, and then we will have on the next line its age, for example 55 years old, and then on the third line we will have its gender. Well, for example, gender will be male in this case. Just print your full name, and then on the next row just print your age and then print your gender. And I want you to solve the exercise in two ways. The first way will be to use 3 lines with a printf command at each line. For example, three different printf commands. First printf command which prints the full name and jumps 1 row down. Second printf prints the age and jumps 1 row down. And the third printf which simply prints the gender. So this would be the first way to solve that, and I also want you to solve it once you're done with the first way, to solve it in the second way, to just use one printf to print all the information you've printed in the 3 lines before. This should not be difficult, just think where you should place the \n in your printf command. Remember that printf can print text to more than just 1 line in your screen, right? Like we've seen in a previous example. And that's exactly the case where we want to do so. So good luck guys, and I'll see you in the next solutions video. So we'll solve this exercise very quickly because it's pretty much the same as the previous challenge. So let's start with the include stdio. Include stdio.h, all the necessary functionality to work with inputs and outputs. Then we'll just go int main, the entry point, curly brackets, and first thing that we want to do is to solve it in the first way. We just want to use 3 printf lines, 3 printf commands. So the first printf command should print something like the first name and the last name. For example, here it's full name, going to be Brad Pitt, as we said previously. And we'll also add a \n at the end to just add a new line. Okay, semicolon. Now on the second printf, we'll just use printf age, right? It was age 65 or 55, I guess, \n, semicolon at the end. And also we'll just use printf, and the gender in this case is male, right? Male, \n, and semicolon at the end. Let's save it. And now if we are to run this program, let's do it this way, build and run. So there you go, you can see all your information. Full name, Brad Pitt. In this example, it's Brad Pitt. In your example, it should be your first name and last name, the age, and the gender. So this information is usually a must for any registration websites and applications that you are going to develop in your future. So this is just the first glance to what we are going to develop once we become experts in programming. So this is it for the first way. And now let's solve it with just one printf line, alright? So we will use just one printf instead of 3, and we can remove both of these lines, and we will just place the \n here. Full name Brad Pitt, and by using this new line we can add also age right after it, age 55, \n to get one new line, and then we'll go like gender, and there you go, gender male, \n at the end, and then we can save it. Now we can build it and run it. And there you go, you can see actually pretty much the same, actually it's identical result with just using one printf line, one printf command, instead of using 3. So both of them give the same results, but you may choose whatever you like. For now, for beginners, I suggest to actually split it into 3 lines as it was previously, like that. So it will be much more easier for you to see what you are printing to your screen. Alright guys? So I hope that makes sense, and all of this program is just sort of an additional practice for you to get yourself more familiar with C language and with C rules and the printf command. So until next time, bye. What is going on, guys? And in this video, in this exercise, we are going to create an isosceles triangle of asterisks. So until now, we've just worked with a simple text, printing our full name and some other information, but now I want you to write a simple C program that all it does is printing an isosceles triangle, just like this one. And this isosceles triangle is just a bunch of asterisks that form this beautiful triangle. And your task is once again divided into two parts, two different ways that I want you to solve this exercise. So the first way that I want you to solve this exercise is by using multiple printf commands. So for example, use first printf command to just display this first asterisk on the first line, and then you may use the second printf command for displaying these three asterisks, and also use the third one to display the last line. Make sure that you also use the space lines correctly here and that you can see on the screen the exact shape as you can see it right here. Once you see that everything is printed correctly on the screen, you move to the second way and use just one printf command. Think about it, how can you use just one printf command to display all of this isosceles triangle? So once you're done, check out the solution video. Good luck, guys. Welcome back. And in this video, we are going to solve the challenge of printing out an isosceles triangle using asterisks. So an asterisk is just like a character that you can print on your screen. Just like you printed out the letter characters of Hello World message, so similarly can be done here. So to solve that in the first way, we can just use three printf commands, right? So on the first line to print one asterisk, we'll use printf and print out one asterisk, and also add a \n at the end. On the second line, we will print three of them. All right, 1, 2, 3, add a \n, and the same for the third line, right? We're using multiple printf commands, so 1, 2, 3, 4, 5, and a \n. There you go. So now if we are to build and run this program, we will see this triangle right here. And we can see that it's not exactly what we wanted, right? Although that's a triangle, we should reorder it a little bit. And that's why the main thing in this exercise is to notice how we can use correctly this line spacing between these asterisks and how we can use the \n, the new lines here, correctly. So first of all, to place the asterisk of the first line at the center of the triangle, we will just add two line spaces here and before the asterisk and two line spaces afterwards. So there will be a total of 5 characters, just like we have at the base. Then we would like to move the 3 asterisks here, okay, on the second line to the middle, and we can do that by just adding one line space before and one line space after. And you can see that right now it starts to make some form, the actual form that we wanted it to be. So on the third line, we'll leave it as is. No line spaces actually are needed here. We already got our 5 characters at the base, as it should be. And now let's run it, guys. Let's build and run. And there you go, an isosceles triangle of asterisk, exactly as requested. Good job. So the biggest trick here in this exercise is to properly use these line spaces and the new line as we explained here. And now, once you've got some experience with that, let's try printing all of this triangle in just one printf line. So first of all, let's clean all of this. All right. And now we will start just like with the previous example and print the first line using these 2 spaces before and after this one asterisk. So printf, here add 2 spaces, add 1 asterisk, and add 2 other spaces. Now that's centered, and let's add the \n to go to the next line. Then, instead of using another printf command, we'll just add the second line, because we will already be on the second line thanks to this \n, right? And here we'll use just one space line and then the 3 asterisks. So one space line, 3 asterisks, another space line, and a \n at the end to go one line down. Now we can print 5 of them at the base at the last line and add the last \n and of course a semicolon at the end. And one thing I forgot to do is to return 0. And hopefully we did everything right. Let's try to build and run it. And there you go. It works like charm. Basically, it's just the same as we've seen previously when we used the 3 printf lines, okay? The 3 printf commands, just that right now we've used it in one printf command. So that's a good practice for this video, guys, and for these exercises. And one last thing for this video, before we finish this exercise, I would like to ask you a question to think about and to try to solve it on your own. We've used a different number of line spaces before the sequence of asterisks in every line. And also we've used the same number of spaces, of line spaces, right after the sequence at every line. Alright, so we can see it right here. There are spaces right after the asterisk as well as here. So the question is, do we actually need it? Do we need these spaces right after we've written a sequence of asterisks? Or maybe we can simply put a \n right after and we'll be good. So in this video we are going to see what are comments and how we can use them in a C programming language. So here we have our previous exercise where we printed alpha text to the screen. Let's say that it's the same as the program where we printed the full name, the first name and the last name. Let's say that it's pretty much the same. Alpha tech is the first name and the last name. Now we can simply add a comment that specifies in just one sentence what this program does. For example, adding a comment like, this program prints out our first and last name. And if we would try to run this code, then we can see that it won't work. We'll just get some errors. And the reason for that is very simple. We didn't specify that this particular line, where we say that this program prints out first name and last name, that this line is a comment. We didn't specify that. If we'll leave it this way, then our computer will think of this line as some sort of command we're expecting it to execute. And that's not what we want. All we want is to specify that this particular line is just a comment, just some sort of a note for us, and not a strict command to the computer. So how can we do it? If we would like to comment a single line in C programming language, then we will just use a / comment prefix. Alright, something like that. This will indicate that this given line is not a command, but rather just a comment for us as the developers. And guys, please note that this comments section, this comments thing, is basically used in all of the programming languages. That's just sort of a concept for developing. You may also use that in other programming languages that you may encounter in your future, such as Python, C++, Java, and any other programming language. The only difference will be just in the way you specify the comment for each language. So for example, here we use the / prefix to specify the comment in C language, and in other languages you may use / while in Python you may use hash character and so on. Alright, so we've seen how comments are used to comment out just single lines. But if our comment happens to be more than just one line, which is definitely something that can happen, then we would like to use something else, right? And in such a case, we would like to use a /* to start a comment block, which may consist of more than just one line of comments, and end this comment block by using an associated * that will indicate that this is it for our comment block. So as you can see here, you may insert a lot of comment lines as part of that comment block, for example specifying some status or whatsoever. In this example we specify what the program does, that it prints the full name and calculates some average grade of a student, and then we also print that the functionality is done and maybe some status about the date and some other information about what should be done in the future and so on. So basically everything that may be necessary for us or for other developer that will see our code in the future. So anything that was written after the slash asterisk and before the asterisk slash should be considered as a comment. So think about what you want to specify in your comments during different parts of your program, and make sure you use comments wisely because they may save a lot of time and a lot of effort for you in the future. Thank you guys for watching this video, and I'll see you in the next one. Bye. Welcome back, ladies and gentlemen, and in this video we are going to talk about format specification. And that's actually a very important video, a very important topic, because it's the basis and the core for some of the following sections that we are about to learn in this course. So in the previous exercises, we've seen that we can use the printf command to display different things on the screen. Different text that was just specified between these double quotes, right? And suppose that you have this following line of code, printf I am 20 years old, a simple line that displays your age on the screen. And next year you're going to be what, like 21 years old, right? Then you could just use printf I'm 21 years old. And if you would run it, you would simply get the same result, just with 21 years old instead of 20 years old. So these two lines are pretty much the same. We have the printf command, and we also have some text, some string between these double quotes. And all I want to do is to simply sort of separate this age, this 21 or 20 years old, this number, out of the string text appearing between these double quotes. Something like that. Simply take a look at this one. Printf I am years old. And then use a comma, and after the comma, just the number that we extracted out of here. And this %d is just some sort of a placeholder which will be simply replaced by the number, in our case 20, that comes right after the first comma. So if you will try to build and run this program, you will see the same text, the same result displayed on your screen as you've seen previously. I am 20 years old. It's the same, right? So what happened here is just that this %d, this placeholder, was replaced by the number 20, which appears here right after the comma. And if we want to change this line to support in the next year, then we should do something like this. We should use printf I am %d years old and just use 21 after the comma. So the %d will be replaced by the first number that comes right after the double quotes, comma, and then this number, this 21, will be replaced here, and it will be printed out to the screen. I am 21 years old. We simply try to print the text that is within these double quotes, and we just need to replace these occurrences of percentage something, %d or percentage something else, with the corresponding value coming after the right double quotes or right after this first comma. Good, good, good. First of all, it works, and that's also an accomplishment, right? Now in the next section, this whole reason why we use the format specification will become much more clear to you, because we are going to study what is an input and how to read an input from the user. And in this section we will also understand the importance and how it's being used, all of this format specification thing. Alright, so now let's take a look at a couple of more examples. So in the first example we will be using more than just one placeholder. So here we have basically two placeholders, two %d right here and here. And both of them are going to be replaced with some values before being displayed on the screen, right? So for the first %d placeholder, we'll have its corresponding first number coming right after these double quotes and this first comma. It's 20, the number is 20, and 20 is going to replace this first %d. So when printed out on the screen, instead of this first %d, we will just see the number 20. And as for the second %d, it will be replaced by the second number here, which is 21. Is that clear? There was nothing hard or complicated so far. Simply printing out some text on the screen by using some new guy that we've just introduced, which is called a placeholder. So let's try to run it and see what happens. Alright, so today I'm 20 years old and next year I'm going to be 21 years old. So 20 for this percentage d and 21 for this percentage d. And also please note that we haven't seen a new line here separating between the real text and this default text, and the reason is because we didn't use a \n here. So that just was a quick reminder for you to not forget using \n at the end of the text. Now for the second example, let's assume that our average grade is something like 93.7. Well, that's pretty good. And if that's the case, you're doing pretty great. So basically now what we would like to do is to print out this grade on the screen. So basically my average grade is percentage d 93.7, and instead of the percentage d placeholder we would like to print this number. And now I want you to open up code blocks and to try to run this line on your own and see what happens. I guess that 93.7 is not exactly what you can see on your screen, right? You've got some strange number, don't you? And for some of you the number printed may also be not so strange, and to be something like 93, just without the remainder of 0.7. But clearly you shouldn't get the expected 93.7 on your screen. So why is that? You see guys, this percentage d placeholder that we've just used here, we also used it in the previous example for format specification. Meaning that this percentage d was used also, let's say, to replace numbers of integer format like 20 and 21. And when you're trying to use this percentage d to be replaced by some sort of a floating point number like 93.7, an unexpected behavior and results will probably be noticed. For example, like you've seen right here. So if you want to use the placeholder and format specification correctly for floating point numbers, then you should use the percentage f. Just something like that. My average grade is percentage f 93.7. And now if you will try to run it, you will see your grade probably with a lot of zeros at the end, which is also okay, right? This is 93.7, and although there are a lot of zeros at the end, the number still remains the same. And in C language you can limit the total amount of zeros after the floating point just by specifying how many digits you would like to see on the screen after the floating point itself. So for example, you specify 0.1 before the f, and this means that there will be only one digit after the floating point. Exactly as you can see here, there are no zeros after the 7. Alright, good. Now you know what is a format specification. These percentage d, percentage f, and many others are simply used as a placeholders with some format specification like we've just discussed. For example, percentage d will be used for integers, while percentage f for floating point numbers and percentage c for characters, and many other options are basically available in C programming language. So I hope that makes sense for you, because we are going to use that a lot in many constellations during our course. So last thing for this video, we've previously said that practice is one of the main things in this course. It's necessary for you to write and execute some code on your own. So I'm going to give you 10 exercises of format specification in the next PDF file, and I want you to try to take a look at them, to think what will be printed to the screen, and also open up code blocks and try to run it on your own. Make sure that what you thought that will be printed on the screen is actually printed out. And if it's the case, so you're good. You know that you covered up this topic in a good way. But if you see that something went wrong, try to figure out why it happened, why the results you see on the screen are not the same as you would have expected. And that's one of the most important things in learning C programming, guys, to practice. Practice a lot, guys. So thank you for watching, and download the PDF file. So what I want you to do is, once you finish the previous video where we learned about format specification, I want you to practice some exercises on your own. You see, knowing format specification is very important and it's actually a prerequisite for our next section. So simply download the attached PDF file and start practicing your programming muscles. Solve these exercises and then test the results by running this code and see if you did it right. So I wish you good luck, guys, and I'll see you in the next video. Welcome back, ladies and gentlemen, and finally, after a good practice to our programming skills, we're getting to our first milestone. And in this milestone, we are going to write a program that will print on the screen the results of 5 mathematical operations: addition, subtraction, multiplication, division, and remainder. And these mathematical operations are going to be done on these two numbers, 5 and 2. Okay, let's take these two numbers, number 5 and number 2. Meaning that I want to see 5 different print commands on these two numbers. Something like 5 plus 2 equals to 7 and 5 minus 2 equals to 3. So these are the exact messages I want to see on the screen. Also, make sure you use the format specifications we talked about in the previous videos, in the previous exercises. That's basically the whole point of this milestone, to correctly use print commands as well as our format specifications. Alright, and one last thing for this video, I want you to note that once you're good with this topic, and once we go over the next variables chapter, you'll be able to develop some real calculator. It will still be basic, but it still will be capable of doing different mathematical operations on different numbers received from the user, and not just 5 and 2 like we do in this milestone. Meaning that in the next section we are going to get more tools to develop more versatile calculator. And I want you guys just to know that this milestone is just the first step in our journey. The first milestone for you to become a legendary programmer. So good luck, guys! Hello there, beautiful people, I'm Tech Teacher Vlad, this is AlphaTech, and in this video we are going to talk about variables. So, variables. This term can really scare some of us, right guys? Some of you have probably encountered this variable thing in your life. Maybe it was in math at school, or maybe in some other programming courses, I don't know. And I guess this topic was not an easy one. A lot of us do not really understand how we should look at variables and how we should properly work with them, but still we're expected to use them without this understanding. It's kind of frustrating, right? But it shouldn't be so scary and frustrating though. I will give you my cheat tips, let's call it this way, and then I hope this topic will become one of the most influencing milestones in your programming life. So now, I want you to clear your mind, take a few breaths, smile, and get ready for the shortest and best explanation there is for variables. So first of all, I want you guys to think of variables as they are boxes. Let's stick with that simple analogy, shall we? I want you to think of variables as simple boxes, and we know some facts about boxes, which are, first of all, the box type. We know that there are a lot of different boxes that may be out there. There may be square boxes, round boxes, small boxes, even large boxes, and so on, right? So there may be different types of boxes, and I just assume that you've seen some boxes in your life, and you pretty much know that they are not all the same and there are a lot of different types of them. Do you agree? So the first fact about boxes is that they have a type. Second, each and every box should have its own name. For example, imagine that you put a sticker on a box to distinguish it from other boxes. A sticker which represents some name for the box, like shoes box, clothes box, a box for books, and so on. This will help you not to mess up all the boxes when you move a house. And that would be the second fact for boxes, which states that boxes should also have a name. Now, what would be the third fact about boxes? We would say that each box may be empty, or it may have something inside of it. It may have some content, right? So we can say that there are basically two main situations we can tell about the inside of a box. Either it's empty or either it has something inside of it. For example, a couple of your shoes, some books, and so on. So that's the third fact, which tells that boxes should either be empty or they should have some content inside of it. And the last fact about the analogy to boxes would be that boxes should be stored somewhere. Simply think about it. If you have some box, then this box is located somewhere, right? Either it sits at your living room, at your sleeping room, at the kitchen, or wherever it may be, this box should reside somewhere. And the place where it resides is called the address of the box. I mean, that makes sense, right? And this address may be represented in different ways. For example, if we take a look at our analogy, we can say that a box's address would be something similar to your house address. You specify where you live, in some country, state, city, street, and so on. So just like you specify your address where you live, the same goes for boxes. Each box has some address. And now, once we've introduced the characteristics of boxes, it will be much more easier for us to learn what are variables. In fact, that should be so easy you'll be amazed how much these scary variables that you may or may not have heard of resemble to these simple boxes we've just mentioned. So all of this story, all of this analogy we've just introduced a minute ago is very similar to how we can categorize variables. So just like boxes, we can say that variables can be of different types. We've said that there are different types of boxes in which you are going to put your books or your shoes. So basically for different type of things, different type of stuff, you are going to use different types of boxes, right? So the same goes for variables. Based on the type of the variable, we are going to be able to store different types of data, like integer, real numbers, characters, strings, and whatnot. So next we can say that a variable should have its own name. And we said that a variable is just sort of a box which has its own name because we know that there may be multiple boxes around and we want to be able to identify them by their unique name. So every box has its own unique sticker, and in a similar way we can say that every variable will have its own unique name. Now each variable may also have some content inside of it. Just like you can pack a pair of shoes, shirts, or even vegetables in a box, similarly can be done in variables. You can simply put some contents, some value inside of variable. That's the whole point of variables, to hold some value inside of it. Now each variable may have some content inside of it. Just like you can pack a pair of shoes, shirts, or even vegetables in a box, similarly you can put some contents inside a variable. That's the whole point of variables, to hold some value inside of them. The variable contents is sometimes also called its value, the variable's value. And lastly, we also know that a variable should have some address where it will reside, right? We need to have an address, some place. Usually it should be a unique place where the variable is going to be stored. So now you know the top 4 features you should be familiar with regarding variables. And in the next short section, you are going to be introduced with the process of using these variables in your programming language. So without any further talking, let's move on to the next video. What is going on, guys? And in this video we are going to talk about how to use variables in C programming language. We are going to talk about variables declaration, variables assignment, and also how to read an input from the user. So in the previous video we've talked about how variables are similar to boxes. Now let's understand how we can create variables. So let's introduce the variables declaration. This will usually be the first step for working with variables, and that makes sense because variable declaration is the same as box creation. So variable declaration is equivalent to variable creation, and it simply states that you just create some variable in the memory of your computer. And how do you create a variable in C language? The structure is very straightforward. First of all, you specify the type of the variable, and then you specify its name, and of course at the end you add a semicolon. For example, if we wanted to create a variable of type integer that will store our age, we would first of all specify its type, which is int, and then specify its name, for example, age. So we have a variable named age, and it is of type int. So once again, this way you created a variable called age and it's of type int to hold integer values. And let's say you wanted to create a variable of type double, which is used to hold floating point values. So in this case, the type of the variable at the declaration phase should be specified as double. Then, in the same way, we will give this variable a name, for example temp, which will be used to hold the temperature in Celsius or Fahrenheit degrees. So just use double temp. Double is the type, temp is the name of the variable, and the semicolon at the end to specify that we've done with our variable declaration. So the structure for creating variables in C language will be pretty much always the same. You first of all specify the type of the variable to be created, then you specify the variable's name, and at the end, of course, you add a semicolon. So to summarize this thing a little bit, whenever you want to work with a variable, you need first of all to create it. And how can you create it? By using variable declaration. Specify its type, then give its name, add a semicolon at the end, and your variable is ready to go. So now let's talk about an assignment operation. So once you have your variable, you may want to put something inside of it, right? Simply to let it hold some value. That's what variables are all about. And this operation, when you want to put some value in a variable, is called an assignment. To assign some value to a variable. So how should it be done in our C programming language? The variable itself has a type, either that's an integer, a floating point, a character, or whatnot. And in most cases, we will put inside of that variable some value that matches the variable's type. So how will it look like in C? Previously we declared or created two variables. The first one was age and the second one was temperature. And we can see that the variable age is of type int, right? We can see it in the declaration phase, int age. That means we expect to assign it a value of an integer type, for example 30. So that's why we use age equals to 30. And we can see the assignment simply taking the value of its right, which is 30, and placing it into the variable called age on its left, a variable which we declared just one line above. So as simple as that, just assign a value to a given variable. And you can do pretty much the same for also the variable temp, which we declared using double temp. You can assign it a value of 26.5 for temperature in Celsius or 76.7 if you're using Fahrenheit, which is the same temperature just in different units. And you can see that the values are floating point numbers. We're using this dot thing, this 26.5.5. This indicates that this number is of floating point type. And that's okay because we declared the temperature variable as type double to hold floating point numbers. Alright, and by the way, in your next milestone, you're going to develop a program that will be capable of making this conversion between temperature given in Celsius to Fahrenheit degrees and vice versa. You're going basically to develop a weather station program, but we'll get to that later on in this chapter. So to summarize for now, the first step will usually be to create or declare a variable, and the second step will be to put something in that variable, or simply saying to assign some value to a given variable. And now we're going to talk about a very important part in this section, and it's called reading input from user, or variable as input. And that's a really important part, guys. It simply explains how your program can be reading data or information from the user. Pretty much as you use forms that you fill on a website. The program that runs in the backend reads every field of this form and stores it in variables. And up to this point, we've learned how to create variables and how to use assignments to them as part of our program. And now what we would like to do is to get the value from the user instead of using the assignment operator. The assignment was done as part of our program, which means we simply used some hard-coded assignment and we set a value to a variable without the ability to give the user, we are the developers, right, and we also have the users, without providing the user with the ability to insert its value to that variable. We simply declared it and then assigned it a given value. For example, a grade is equal to 30. And what is the problem with that? Basically, there is no problem with using any of them. There is only a difference between when one should be used over the other. So once again, there may be cases where we would like to use assignment operator, and there may be other cases when you will need to use the input thing to get some information directly from the user, as we are going to see in the following examples. So suppose you have to write down a program that should calculate the average of two grades. One way to do so would be to define these two variables by using the assignment operation to set their values to, let's say, grade 1 equals to 80 and grade 2 equals to 100. First of all, we know that an average of two grades can be calculated by summing both of them and dividing the sum by 2. So the average would be simply 80 plus 100 divided by 2, which gives us a total of 90. So we can simply use the printf command to print to the screen that average equals to %d, and instead of this percentage, we will just replace it with a total of 90, right? The expression that on the right of the comma. And that's great, it would work, but in this example, we define the two grades. We as the developers. We've simply created a program that will always print the average for these specific grades when grade 1 equals to 80 and grade 2 equals to 100. And I guess you noticed that this program is not generic. It will always print the average 90, always print the same, unless we manually change the grades. And in such a case, we simply cannot sell or ship this program to customers because the program does not know anything except these two grades, 80 and 100. We want to give the user the ability to insert his own grades, and then our program will calculate the average grade and give the result to the user. And that's exactly why we learn to work with inputs. Now let's take a look at the syntax of how that should be done in our C programming language. So if we want to create a program that calculates the average grade of two given grades, we first of all need to declare these two variables. So we created grade 1 and also we create grade 2. And at this point, these two variables are kind of empty. We say that they contain garbage value that cannot be used. And we could assign some values to them, like we've seen previously, something like grade 1 equals to 80 and grade 2 equals to 100. But that's not exactly what we want to do. What we want to do is to read the grades from the console, to read the grades from the user. We want to let the user to provide his own grades, so then any user will be able to use our program with his own grades. And to do so, we'll use one little function that will help us with that. And this function is called scanf. So the syntax in C language for the input of the first grade looks like this. Scanf %d ampersand grade 1. Don't panic just yet. Let's try to understand the structure of this command together. This function simply reads the value we insert in the console and it refers to this value as an integer. That's why we have this %d, right? Just like we used %d in the printf command to print something to the console, now we are reading from the console the input that the user will provide us with, and we treat it as an integer thanks to this %d. Pretty simple, right? And the value itself will be stored inside of grade 1 variable, which we've just created. And this ampersand sign, all it does is to specify that the value read from the console using this %d should go and be placed at the address where grade 1 resides. So once again, read an integer from the console and put it in the address where grade 1 resides, or simply put this value in grade 1 variable. So pretty much the same way we'll do this for grade 2. So now at this point we have two variables, grade 1 and grade 2, and they hold the grades that the user just provided using this console. And now let's print the average of them on the screen. There are actually a couple of ways that we can do it. One of them is just to write the mathematical operation in one printf line, something like that. printf average equals to %d, and then to write the mathematical operation as we've seen previously. And there you go, your average grade should be printed on the screen, average equals to 19 in our case. Pretty cool, right? Try to run this code on your own, open CodeBlocks or Visual Studio or wherever IDE you use, and try to run this code on your own and see how it works for you. One thing to mention here is that we didn't speak about anything related to casting, and that's actually the result of dividing the sum of your grades by 2. This result may be actually a floating point number, something like 97.5, and in our case it won't be printed correctly. The only thing that will be printed on the screen will probably be just 97. It will be just rounded. So one of the ways to handle that is to use casting. But for now and for this video, I think that's enough. I hope you got the idea of how the function scanf works and that you are ready to move on for your next challenges where we will practice that even more. So I wish you good luck, guys, and I'll see you in the next. So before we move on, I want to show you guys how using an input will look like in real code and how you're going to actually use the console application to read inputs from the user. And the first example I want to give you is a simple program that reads a number from the user and then prints that number on the screen. So for that, let's first of all create or declare a new variable, and let's call it num, int num. So here we just created a variable called num, its name is num, and it's of type int, alright? And now, just for the explanation, let's assign some value to num. For example, let's call it num equals to 10, alright? And before we actually use inputs to read the data from the user, we'll just use the assignment just to show you. It will be much easier for me to explain to you guys. And now I want to print this num on the screen, so for that I'm going to use printf and just print num is %d %n and just replace the %d with the num itself, alright, semicolon at the end, we save it, and now if we are to run this program, let's build and run it, you can see right here in the console application num is 10, alright, we learned it so far that printf prints some message, some text to the screen, to the console application in our example. So num is 10. Great, so now if we run this program once again, let's run it once again, we can see that the result is going to be the same. And if we run it once again, the result is also always going to be num is 10 in such a case, alright? Even if you run it 100 times or give that program to different users, you will still get the same result. And the reason is that you assigned a value to num in sort of a hard-coded manner, num equals to 10. So now we will not assign a value of 10, but rather we're going to give the user the ability to insert the value on its own. And you can do that by first of all removing this assignment, okay, num is not equals to 10 anymore, and we'll just use the scanf function. So scanf, exactly as we've seen in the previous video, %d, because we are reading an integer, right? And we are going to put it inside of num, alright? The ampersand specifies the address where this variable num resides. And now if we build and run it, we can see this kind of prompt, this console application that expects you to insert some value. So let's just insert, let's make it 5, alright? And once you hit the enter button, the value itself you've just specified is going to be inserted in this variable num, right? It's going to read it from this console application, from this prompt, and just put it inside this num variable. So press enter, and there you go. You can see the message num is 5 printed out on the screen. So now if you try to run this program once again, let's do it once again, run, and just insert here, I don't know, 100. Alright, so the result is going to be different than the previous one. So now we will get this 100 once we press the enter button. We will get this 100 inside of this num variable, and then we are going to see num is 100. So let's check this out, press enter, and there you go, you can see num is 100. And that's how you use variables and how you use inputs in C programming language. This simply means that we created a more generic program that different users may use it and insert different values. And we'll see in the next examples why is it so useful, as well as not only in the next examples, we will see it also during the whole course. Hi there guys, that's time for a challenge. I want you to write a program that gets as input from the user the following variables. First of all, the current year, for example 2020, and also a user's age, for example, let's say, I don't know, 30. And this program should calculate and print the year that you were born, the year that the user was born. So for this example, the program should print 1990, which is just a subtraction of your age from the current year. That's just 2020 minus 30, and that's a total of 1990. Is that clear? Please note that in this exercise you shouldn't initialize these variables by just assigning them some value in your code, but rather you should use the functionality we've just learned and read these values from the user as input. The whole point of this exercise is for you to implement the knowledge you've gained so far, and that you will write a generic program that will be basically be capable of shipping to customers, and that they can just insert the current year and their age, and they will get the answer to the year that they were born. So take a couple of moments to try and solve this exercise on your own, and I'll see you in the next video where we'll go over it and solve it together. So basically we were asked to write a program that will get as an input from the user two variables, current year and user's age, and then make some calculations on these two variables. But let's leave that aside for now and just focus on the first part. We need to get as an input two values for our two variables. And in the previous videos we've said that if we wanted to use variables in our program, then the first step to do is to create them, to declare them. So that's exactly what we are going to do right now. So let's first of all declare these two variables, int current year, right? It's the first variable. And let's declare also the age variable, int age. Both of them are of type integer. The first name is current year and the second name is age. So at this point, these two variables are kinda empty. They contain no real value at this point. And one of the options to set their values is to use assignment and to give these values, I don't know, something manually. For example, we can use current year equals to 2020 and age equals to 30 as we used in our example. And that's exactly what we don't want to do. We should read these values from the user and not assign them manually as we're doing here. So the first thing that we do is scanf, alright, %d. Why? Because we use two variables of type int, and then we use a comma, ampersand, and current year, alright? That's how we scanf as an input from the user the current year. And also let's do the same for the age, scanf %d, ampersand age. This once again means the address where the variable age resides, alright? So take the value from the prompt, from the console application, read it, and put it inside of this variable, alright. So in this way we'll be able to read these values from the user so that different users will be able to insert different values in a more generic way. So now at this point, at this line, for example, line 12, after the two scanf lines, and all that remains now is to calculate and print the results, to print the year you were born to the screen. So to print something to the screen, we should use the printf function, right? Printf. Alright, so what should we be printing to the screen? So we should be printing something like that. You were born in %d \n, right, to get one line down, And here we should use our expression to find out the exact year that you were born. And that could be done just by subtracting the age of the current year. Current year minus age will give us the exact year that the user was born. And there you go. Now we can build and run this program and to see the results on the screen for ourselves. So let's build it and run it, right? So now let's place, first of all, we need to enter the current year, for example, 2020. All right, and now the prompt waits for the age. We should also put here the age, let's say, as we've done in our example, 30. Let's press enter. And now you were born in 1990. Oh, so that's cool. You can actually find the year that you were born. Let's try another example. Let's say, all right, let's say, so the year right now is 2020. And for example, you are 57 years old. Let's say 57, press enter. And we can actually find out the year that, for example, your father or grandfather was born. You were born in 1963. Great. All right, so we've successfully completed our challenge. And by the way, some of you may have also tried some other ways, some other solution by using an additional variable to hold the calculated value of the birth year. So you probably used something like that. You declared another variable called birth year. All right. And then before you printed out something on your screen, you just used something like that, birth year equals to this guy. All right, equals to this guy. And then instead of writing any mathematical expression here, you just use the birth year, right? Something like that. And that's totally okay. It should work the same way. We simply previously didn't use any additional variable as opposed to this example where we created another temporary variable that helped us with this calculation. But if any of you solved this exercise with additional variable like we've seen here, there is nothing wrong with it. It will simply work the same way. So this is it, guys, for this video. I hope that everything runs on your side as well. Write relevant notes for you from this challenge, different examples, different ways we solved this exercise, and prepare yourself for the next challenge. I'll see you there. Welcome back to another challenge. And at this point, you've already done a couple of these exercises, of these challenges on your own, and I really think you start feeling an improvement in your skills. And all that's remain is simply to improve these skills even more. So in this challenge, you have to write a program that gets two double numbers, not integers, from the user, and these numbers should represent a given rectangle. The first number should represent the height of the rectangle, and the second one should represent its width. So your program should simply print to the screen the area of that given rectangle. And for those of you guys who forgot how a rectangle's area is calculated, that's simply done by multiplying its height by its width. For example, if a given width is 4.2 and height is 3.5, then the program is going to print the result of 4.2 multiplied by 3.5, right? That's how you calculate the area of a rectangle. And in this case, the result would be just 14.7. All right. So there you go. I hope the instructions are clear, and I wish you good luck, guys. And please do not proceed to the next video until you've tried your best to solve that one on your own. I'll see you in the next video. So in this challenge, you were asked to calculate the area of a given rectangle. And to do so, you were asked to create two variables of type double height and double width. And well, these two values should represent the height and the width of the rectangle. So let's first of all print some nice message to the user, printf, specifying him to enter the height and the width of this rectangle. So for example, let's use enter height. All right. And also we'll use something like that, printf enter width. There you go. Now we should also add a functionality to read from the prompt, from this console application, the actual values for the height and the width. And this can be done using the scanf function. So scanf %lf. Alright, we're using %lf for double variables, and we'll place this value inside of height variable. So please note that we don't use here %d, which is used for integers, or %f, that is used for float variables. This variable is of type double. Alright, so also we'll add something like that, scanf, pretty much the same, %lf to place the value that we read from our prompt to the variable width, semicolon at the end. Very good. So at this point we should already have our two values that represent the rectangle's height and width. And now all that remains is simply to create another variable, another double variable, and call this variable area. This variable should hold the result of multiplying height and width to represent the area of this rectangle. So height multiplied by width, semicolon. And now we should just print the result to the screen as we were asked in the exercise in the challenge itself. So printf, the area of this rectangle equals to %lf, alright, %lf, because we use double type variable. And here we will just specify area. So now let's save it and build and run this program. And there you go, you can see your console application. And here is your first message. You use the printf command to display this text on this screen, so enter height. And here is a prompt. The scanf is waiting for you to insert some floating point long number. So let's use something simple like that, 4.2, and there you go for the second message, enter width. Let's go with something like 5.7, and once we hit the enter button, this value, this 5.7, is going to be placed inside of this variable, inside of width, the same way as it was done using this height. Where we just specified 4.2, it was placed inside of this variable. So let's hit the enter button, and there you go, you can see the actual message displayed here. The area of this rectangle equals to 23.94000. We can limit it, we've seen it in the previous section. We can limit it to just two numbers, two digits after the decimal point. So one last thing I want to add here is to use a new line between this information, this area of this rectangle, and separate it a little bit of this default message that it won't confuse you guys. So let's just add a \n here and save, build and run it once again. And let's do something like that, 3.2, 5.4. And there you go, you can see the whole separation, and you can see this line representing all the information that you need. So to summarize everything up, we simply developed a program that we can ship to different users. This program is intended to be used by people who just want to find the area for a given rectangle that they have. So they have the values for the height and the width, and they want to find out what is the area of this rectangle. Instead of, instead of just using a calculator, they just want to use your awesome program. And that's exactly what you provide, what your program provides. And although it's a simple program, it's also a start, and you can see how we are moving forward, how we are getting better every day and every section and every video and every challenge. So I hope you can also see what is going on, guys, and welcome back to our C programming course. My name is Vlad, this is AlphaTech, and in this video we are going to talk about a really important topic called casting. So we know that in C language we can create different variables of different types to hold different data. Now if we've come to think about mathematical operations, then a sum of two integers should definitely also be an integer, right? And also we can say that the sum or the division of two floating point numbers is also expected to be of a floating point type, meaning that if two numbers are of the same type, then usually we would have expected the result of any math operation between them to be of that same particular type, like we can see right now. But that's not always the case. Suppose you've got two integer numbers, let's say 5 and 2, like we've seen in one of our previous challenges, and you want to find out what would be the result of dividing 5 by 2. So on one hand, we know that 5 and 2 are two integers, and we expect, as we've said previously, that the result should also be of an integer type. Then we can say that 5 divided by 2 will give us just 2, right? This means it can be interpreted as how many times the number 2 can fully be inserted into 5, and that's exactly would be 2 times. On the other hand, if we expect and allow the result to be of type floating point, then we can definitely say that the result will be none other than 2.5. So as you can see here, pretty much the result of the same mathematical operation can give you basically two different results based on the type itself. And when and how to use it correctly, we are going to discuss right away. So for that we'll need code blocks, and first of all let's define two variables of type int, num1 and num2. So int num1 and num2. And also let's create a third variable that will simply store the result of the division, and it will be something like int result. So once again, this variable result is of type int, and it will simply be used to store the result of the division between num1 and num2. So now we can say that result will equal to num1 over num2, assuming that num2 is not 0, right? Assuming num2 is not equals to 0, alright? And then we will just use the printf message to print out the result to the screen. We'll say result equals to %d \n, and then we will go with result. But before we build and run this program, we kind of forgot something. We forgot to initialize these variables, so let's put it num1 equals to 5 and num2 equals to 2. And now if we save and then we build and run it, we can see that the result should be, that the result is actually 2, right? We divided 5 by 2 and the result was simply 2. So that's okay. Let's try to figure out what will happen if we simply to change this result from integer to a floating point. For example, let's use double. So now if we are to use double, we will simply modify this %d to %lf, and then we will use the result as we used it previously. So save it, build and run, and there you go, still 2. But now it's 2 with a bunch of zeros afterwards. So why is that? Why again do we have the result of 2 when we've defined it to be of type double? We defined the result variable to be of type double. So we expected the result to be something like 2.5, right? The division between num1 and num2 should give 2.5, but still we got just 2. So what happened? Let's try to find out. The result variable is of type double, and it basically does contain numbers of that type. We saw on the screen 2.000 is actually a floating point representation. And if we were to take a closer look at this line, line 8, we can see that on the left side of this assignment operation there is this result, and it will simply hold the value represented as a floating point number. But what interests us here is actually the right side of this assignment, num1 over num2. And this leads us to the first rule I'm about to tell you. So the first rule I want you guys to know is that whenever you make any mathematical operation between two numbers of the same type, in this case it's integer and integer, right? So whenever you do any mathematical operation between two numbers of the same type, the result you will get by default, it will be actually of the same particular type, right? We saw it previously in the slide itself. I discussed it in just a couple of moments. So the result of this guy, of this division, is going to be also an integer, because both num1 and num2 are of type int. So the result is also going to be of type int. And please notice that the result itself on the right side, before, and I emphasize this, before it is assigned to the result itself, there is some mathematical operation going on here, and the result itself, before it is being assigned, is an integer number. So whenever you divide 5 by 2, it is round to the lowest number, which is in our case is simply 2. And now, once the right side has been calculated, has been found that it's 2, only now we take this 2 as an integer and we assign it to result. So the result will refer to this 2 as 2.000, alright? So it will be something like that. It was 2 at the first place, and then it became 2.0, instead of being just something like 2.5 as you would have expected, right? And I hope this one is clear for you and you got the point. So let's proceed to the following question. How can we divide 5 by 2 and still obtain 2.5 as the result of it? And this leads us to the second rule, and I call this rule an implicit casting. And the reason why it's called implicit is because this casting is being done behind the scenes, and we don't explicitly specify that we want to make type conversion. So the second rule, the implicit casting, states that whenever you make mathematical operation between an integer and a floating point number, the result of this operation will be always treated as it would have been done between two floating points, meaning that the result would be of a floating point type. So for example, if we take the number 3, which is an int, and add it 4.5, which is of a floating point type, then the result would be also of a floating point type, which is 7.5. And it's a floating point type, although 3 is an integer, right? So in addition to any plus and minus operations, this will also work for the division. So if we change even one of these numbers, num1 or num2, let's leave num1 equals to 5 as an integer, and we'll just use double num2 equals to 2.0, which is pretty much the same. So in this case, if we are to run this code, we'll see a different result. Let's try to build and run it. Build and run, come on. So the result is actually 2.5. And leave aside these zeros at the end. And that's exactly what we expected, which is great. So another option would be simply to use, instead of num2 as a double, we could still leave it as an integer, int num2 equals to 2, and just modify num1 to be of type double, num1 equals to 5.0. And if you try to build and run it, you will see pretty much the same result, 2.5. And that happens because it's sufficient for us that even if one of these numbers that participate in this division operation will be of type of some floating point type, then also the result, before it is even assigned to this result variable, the result itself will also be treated as a floating point. And that's the reason why we don't lose any data in this type conversion. Alright guys, good. But suppose that you've begun your program by setting up both num1 and num2 to be of type int, something like what we've done previously, num1 equals to 5 and num2 equals to 2. And you don't want to change their type for some reason, I don't know. Maybe the boss demands that these two variables should remain of type int, but you still need to calculate these results somehow. So for that we will use a technique called casting. We know that thanks to the second rule, we said that it's enough that at least one of the participants in the mathematical operation would have been of floating point type, so then the whole result would have been as a floating point. And we also know that in this case, both num1 and num2 are of type int. So basically what we have to do is simply to take at least one of these numbers, num1 or num2, and cast them, explicitly use casting, into double, for example. And it will allow the computer to treat that mathematical operation as it is being done between two floating points number, which is exactly what we want. So to use casting, for example, on num2 in this case, let's define something like this one, double. So we simply use the parentheses, and inside of these parentheses we specify the type of the casting that we want to make on this num2. So for example, we know that num2 in such a case, let's remove this one, we know that num2 in this example equals to 2. And if we add this explicit casting before, alright, this casting will be applied on num2, and it will simply change it from 2 to 2.0 to a floating point representation. So in this case, if we save it and build and run this program, we will see the expected 2.5 printed out on the screen, although we used num1 and num2 as integers. So I hope that makes sense to you guys, and also you're not required only to use casting on num2. You may also use this casting on the first num1, on the right here, alright? And if you are to run and build and run it, better say, then the result is also the same. It's 2.5 also here. And all of that thanks to the second rule, where we've defined that it's sufficient for at least one of the participants to be of type, for example, of type double, then the whole result of this operation will also be of type double. And then we can simply assign this result to the result variable on the left of on this assignment operation. And also, please note that the type of neither num1 or num2 after the casting operation will never be changed. Both num1 and num2 will still remain of type int. They were just converted, or better say casted, to be, for example here, just num1 to be of type double, just for this operation, just for this line. So hopefully this casting makes sense to you guys. You could basically just also use here double on both of them, both for num1 and num2, and it will not change the result at all, because it will already be treating this operation, this mathematical division, as an operation between two floating point numbers. So simply saying, you can basically cast whatever you need. For example, you can cast a floating point to an integer, and this can be done by something like that. You specify in the parentheses the type that you want to cast a given value, so let's say int, and then you specify the floating point representation 5.1, and all of this expression, all of this everything we've written here, it can simply be treated as just 5. This will simply be an integer representation of this 5.1. And also you can do the same for 7.95, let's say 7.95. So after this casting operation, this casting to integer representation, we will simply stay with just the 7. So I hope that's clear for you guys. And to summarize everything up, casting is a very important topic you must be familiar with, because you will encounter it a lot in our programming career. And you must know how to tackle problems with casting, how to use them, when to use them, and basically whether it should be done implicitly or explicitly or whatever you like. And one of the examples is going to be shown in the next challenge, where you will have to calculate the average grade between three given grades from the user, because previously we didn't, when we solved this exercise of the average grade, we didn't specify, we didn't talk about anything related to casting, right? Because an average grade will not be in integer representation, but rather it will be a floating point number, so that just now we know how to handle it and how to take care of all of these casting. And of course, guys, there is much more depth to these rules we've just seen, and many nuances that should be taken care of. But that will be for another course, because these topics are much more advanced and require the understanding of lower levels. So hopefully you'll find this information valuable for you for now, and I will of course share my knowledge with you in the next advanced courses that I'm planning to create just for you. So thank you guys for watching, and I'll see you in the next challenge where we will solve and practice our casting skills. Welcome back to another challenge, and you should solve this challenge right after you've studied casting. So in the previous video we've talked about casting in general, as well as we've seen a couple of examples to how casting can be used in C programming language. And now I want to go back to one of the first exercises we've done where we calculated the average grade between two given grades. And so in this challenge I want you to write a program that reads from the user 3 grades of type int, of course, and then the program should print the exact average between them. And by saying the exact average grade, I mean that it should be of a floating point type if necessary, with this dot precision, and not round to any side just to keep it as an integer. So for example, if the calculated average grade is something like 92.5, then that's the exact number that should be printed on the screen. And not just 92, as we've seen that may happen if not using casting correctly or not using casting at all. So once again, in this exercise you have to apply the casting process. The average grade should be calculated between the given 3 grades. The grades must be of type int, and the printed result, the average, should be of a floating point type. Meaning that if the final grade should be, let's say, 85.7, then 85.7 will be printed on the screen, and it will not be round to any integer like 85. So I hope you've got the point. That's not a complex exercise, it's just to emphasize and practice a little bit the topic of casting that we've just learned. And I wish you good luck, and I'll see you in the solutions video. What is going on, guys? So let's get down to business right away. We need to create 3 grade variables, grade 1, grade 2 and grade 3. So for that we'll use int grade 1, grade 2 and grade 3, semicolon at the end, Control S, we save it. Now let's print some nice message in which we will ask the user to insert its first grade. So we'll use something like printf enter grade 1. And now let's read grade 1 from the user and put this value inside of variable grade 1. So we can do it by using scanf %d, because we are reading an integer value, and we will place it inside of the address where grade 1 resides. Alright, this is good. Now let's do the same for both grade 2 and grade 3. Okay, so copy paste and copy paste. Printf enter grade 2, and the same here, grade 2, and here we will enter grade 3 and read grade 3. There you go. Also, let's define here another variable called average, and we will set it to be of type double. So use double average. This variable should hold the average of the 3 grades we've just read from the user, alright? So at this point we can basically say that the average of the previous 3 grades read here on this line of where we use scanf, the average should be something like that. Average equals 2. Let's sum all of the grades, so grade 1 plus grade 2 plus grade 3, alright, and just divide it by 3, semicolon at the end. And now let's think, will it work? I want you to pause the video and take a second to think about it. So the answer to this question is absolutely no, because we've just talked about how important it is to use casting to get the exact grade, assuming it may be of floating point type. And we've learned a couple of ways in which we can accomplish that. So in this example we can see that on the right side of the equation in line 14, you can see that both the participants on the right side here, right, here is the 3, and also all of these sum, both of them are basically integers. And we know that the result of this mathematical operation, we've said it previously in the video where we discussed casting, the result of that is also going to be of type int, meaning that if we get here on the right side an average grade of something like 85.7, if we should get this value, basically it will be just round to 85, and then we'll lose the whole point of using this exercise. So for that we need to use casting, and basically we should simply define one of these or numerator or denominator to be of type double, of a floating point type, for example. So the easiest way to do it, we can simply just add a .0 at the end, and what we've basically done here is we simply say that this value, instead of using 3 as it was previously, just an integer, that this value is of a floating point type. And this means that the result of this whole operation, of this whole division, of this sum by this 3.0, the result of it is also going to be, by default, it's also going to be of a floating point type. And that's exactly what we want to do. So let's now print the result, print the average grade. So printf average equals to %lf, because we use double. Actually, there is no real necessity to use double here. We can basically just use float, but let's leave it as is for now. And here we will use the average, semicolon at the end here. All right, now let's build and run it. Oh, and we have a little problem here. What's the problem in line 14? Average equals to grade 1 plus grade 2 plus grade, oh, I forgot the 3 here, divided by 3.0. All right, so now it should be good. Let's save it and build and run it once again. And there you go. Here is our console application. Now let's use some example here. Let's say it was, the first grade was 80, and then we had 60, then we had, I don't know, 95. So every time you pressed enter, just to remind you guys, the number itself you pressed here was inserted, was placed inside of the corresponding variable. So in this example, grade 1, and then grade 2, and then grade 3 once we press the enter right now. So let's press that, enter, and there you go. There is your average grade, equals to 78.333. We can limit that by placing here .2. And also, of course, let's add a \n at the end just to separate it from the default text. Let's build and run it once again. Let's give it something like 75, 65, and not 100. Let's do it like 97. There you go, 79.00. We limited it by putting a .2, which simply says you can place just 2 digits after the floating point. Alright, so we almost finished this exercise. Just one last thing that I want to show you guys in this example. We can also leave the 3 as it was previously as an integer, and instead we can just take any of these variables here on the left side. We can take any of them and just cast them to be of type double. This basically will be enough for the whole operation, for the whole math operation, to treat it as a floating point number. So we can basically do something like that. Just add here double casting, and now all of your result will be treated as a floating point, and it will work okay without any round to the smallest integer. You can also do the same for the second, oops, sorry about that. There you go. You can also do it for the second grade. It doesn't matter, okay? So basically, I hope you've got the idea of how to use casting, and you practice it with this nice little exercise of using 3 grades. And actually, yeah, I can say that I think that you're ready to move on to your next milestone. And actually, the next milestone is very interesting milestone, because you will develop in this milestone a weather station. Welcome back, ladies and gentlemen, and in this milestone you are going to develop a basic weather station. This milestone consists of 2 exercises. In the first one, you have to write a program that gets from the user some temperature of double type, and this temperature should be represented in Celsius degrees. The program should calculate and convert the temperature from Celsius degrees to Fahrenheit degrees and print the result to the screen. And the formula for the conversion from Celsius degrees to Fahrenheit degrees can be seen right here. Basically what it says is simply get the temperature in Celsius degrees, what the user enters, then multiply it by 1.8 and add a 32 to it. And that's how you get the temperature in Fahrenheit degrees. So that's the whole conversion story. Just a simple mathematical equation, nothing more. So for example, just check it out at home. If a user inserts a temperature of 26.5 Celsius degrees, then this temperature will be printed in Fahrenheit degrees, something like 76.7 if I'm not mistaken. Alright, so that's the first part of this milestone, to convert from Celsius degrees to Fahrenheit degrees. And now we can move on to the second part, where we are going to receive from the user the temperature in Fahrenheit degrees, and then to convert this temperature from Fahrenheit to Celsius degrees and print the result to the screen. Pretty much the same as the first part of this milestone, just that right now you probably have guessed it right, the formula of the conversion is going to change, to be changed. So the formula in this case is going to be something like that. Simply get the temperature in Fahrenheit degrees from the user, subtract 32 from it, and then the whole answer, the whole result so far, divided by 1.8. That's all. So now you know the two formulas to convert from Celsius degrees to Fahrenheit and vice versa. And all that remains is simply to write the code, to write the program to support the functionality of this weather station. And I'll leave it to you guys, try it on your own, don't give up, be focused, stay focused, and I wish you best of luck. I'll see you in the next video. What is going on, guys, and thank you so much for getting this far. You're doing a great job, and I can guess that you will, if not already, see meaningful results. In this tutorial, I want to talk about a situation where we have these two variables, a and b, and each of these variables has some value within, alright? And for some reason, we have to swap between these two values. So for example, at the beginning we have some box A with a value of 10 and a box B with a value of 20. And what we need to do is just to exchange the values within these boxes. So if at first we had a value of 10 in box A and a value of 20 in box B, then after the exchange there will be a value of 20 in box A and a value of 10 in box B, just as we can see it in this demonstration. And basically you can think of this situation of swapping between the values, the content of two different boxes, as just two boxes with some pairs of shoes. One box has men's shoes and the other box has women's shoes. So for example, in box A we have 10 men's shoes and in box B we have 20 women's shoes. But it turns out that box A, that should contain women's shoes, basically contains men's shoes. And that's why we need to replace all the shoes from box A with all the shoes from box B, right? So what would be the trivial way that you would solve this kind of task? You can't just simply take and pour what is in one box into the second box and vice versa simultaneously. Because in this case there will be just a mix of all the shoes in every box, and that's not what we want. What we want is probably to get another box and call this box temp. And this box will be used to assist in this exchanging process. So first of all, we will take the value of box A, which is 10, and just put it inside of box temp. Then we will take the value of 20, all the shoes from box B, and put them inside of box A. And finally, we will take all the shoes, all the value itself of 10 from box temp, and put this value inside of box B. And now the exchanging process between these two boxes A and B, we can say that it's complete. So basically you can see that the value of 10, which was previously in box A, is now at box B, and the value of 20, which was at box B, is now at box A. Whew. Alright, very well guys, that was kind of rough explanation using a real life situation. And now what I want us to do is to be more close to the programming world. I want us to write a simple code, a simple program that will use this swap thing in our programming language, so that you will be able to take your skills even one step further. So I hope this topic is clear for you and that you are ready to move on to the next video for swap in your programming language. I'll see you there. So suppose you have a variable a that stores a value of 10 and also you have a variable b that stores a value of 20. Nothing complicated so far, right? And now your task is to swap between the values of these two variables. And you may think to use some assignment statements that on one hand they may seem to be pretty much okay, something like that, a equals to b and then b equals to a. But you can see what happens behind the scenes. So let's take a look at this whole process once again. Let's just undo these last two operations. And there you go, now we can see it once again. So in the first line where we say a equals to b, a gets the value of b. This means that a has a value of 20 as well as b also has its own value of 20. So at this point both of the variables hold a value of 20. And the next line of code is actually useless because a already does not hold the value of 10. The value of 10 is, at this point, it's lost. So if we write the second line of code where b equals to a, we just get the same 20. So in this way we can say that the swap operation has totally failed. And to solve this problem we may use a similar approach to the one we used in our previous example. So for us to swap between these two variables we will use additional variable that will help us with our task. We will call this variable as we called it previously, we will call it temp, and it will be of the same type as the variables a and b, and in this case it's integer. And this temp variable will actually help us here, just like it helped us in the previous example with the shoes and the swap in general. So before we do any swap operation, let's first of all print the values of variable a and variable b to the screen. This way, once we are done using our swap operation, we can see on our little console application the results, the actual values of variable a and b before the swap and after the swap, just to make sure that everything was okay. And now all that remains is simply to use the similar approach that we've seen in the swap general explanation, and basically to say that temp will get the value of a. So temp equals to a, and there you go, you can see that 10 is now stored also in variable temp. And then you just write a equals to b, and then the variable a gets the value of b, and then you write b equals to temp, and the value of 10 goes from box temp to variable b. And now we can say that we are finished with our swap operation. We can see that variable a contains the value of 20 and variable b contains the value of 10, which is exactly as expected. And what we also would like to do is simply to print the values to the screen to make sure that our work has succeeded. So we will just use printf a equals to %d and print the value of variable a after the swap operation. And we will do also the same for variable b, so just printf b equals to %d and just print the b value to the screen. So this way you can make sure that all the operation, that you can see the values before the swap printed to the screen and also after the swap printed to the screen. So there shouldn't be any mistakes here, right guys? But there are also maybe times when the interviewer will tell you to implement this swap operation thing without using a third variable, without using this temp box. And that's actually also possible in many ways, as a matter of fact, but I'll leave it for another video, so let me know if you would like me to create a dedicated video just for this topic, how to perform a swap operation between two variables without using a third variable. I'm tired after this swap thing. So as always, thank you guys for watching, and I'll see you in the next video.